Hello everyone, welcome to this Swayam course on DIY manufacturing technology offered by the National Resource Center for Design and Manufacturing at Indian Institute of Information Technology, Design and Manufacturing, Kancheepuram. In today's lecture, we are going to basically visit an industry. SVP Lasers is an industry which is catering to the needs of the academia as well as industry. They are into the product development in the CNC routing as well as other kinds of machines, CNC machines. So they make a variety of CNC machines, and then today I just posed him a lot of questions about CNC entrepreneurship as well as the industry ecosystems around CNC. So one of the very important milestones that this company has reached is they have won recently award from CA. So let's just hear from him.
SVP Laser, basically we are a company, we are developing various digital manufacturing related products and services. I am an alumni from IIT Madras. I graduated in 98 and did my master's. Yes, at SVP Laser, basically we are a company, we are developing various digital manufacturing related products and services. I am an alumni from IIT Madras. I graduated in 98. I did my master's in US, worked there for a few years. Then about 10 years I worked in various companies like Siemens and then we are running this company for about last 7-8 years. We are developing various products like CNC, subtractive prototyping machines, CMMs, robotics machines, automation. We are developing indigenous CNC controllers, CAM software, and various digital customized CNC machines for various industrial applications like jewelry manufacturing, PCB manufacturing, foam manufacturing, furniture manufacturing, and so on. We live in a country where our washing machines, our cell phones, our LED lights, even our mosquito bats are not made in India. So we hope to play our part in the Make in India, which is our national mission, and develop at least 100 made in India products. That is our long-term vision and mission of our company. Regarding what kind of digital machines, the CNC machine, 3D printers and all that, there is a whole gamut of technologies. Everybody thinks 3D printing is the only rapid prototyping method. That is a very important technology, but there is a whole other gamut of technologies has to be manufactured. Rapid prototyping means rapidly developing a real product. That involves there are various other machines like CNC machine, CNC gas cutting, plasma cutting, CNC wire bending, injection molding, thermoforming machines. Like that, there is a whole gamut of technology, CNC foam prototyping machines and so on. So, for example, MIT is recommending what is called a fab lab, or they are also promoting this concept called a fab city, where this fab lab is basically a set of digital manufacturing machines are available. It can be set up in a small lab in a college, or it can be set up in a city library, or it can be a common infrastructure for some like a smart city what we are trying to develop. So these digital manufacturing machines go into these fab labs and enable students, citizens to do a lot of innovation, a lot of DIY. Today, unfortunately, even though CNC is there in the AICTE syllabus for the last 20 years almost, engineering colleges still use the CAD/CAM lab to teach students how to write G codes, M codes, to do toolpath simulation and all that. Nobody is really using the power, the real prototyping power, product development power of these CNC machines. So my recommendation, my request to the engineering college faculties, students also is to realize the powerful product development potential of these CNC machines, CNC 3D printers and various other digital manufacturing machines, and to come up with the product innovations much faster. The first step towards innovating or developing a new product, inventing a new product, even before that, that comes at a very mature stage. At a student level, what you can do is you can start what is called learning by doing. That is the very first step. Once you start doing things hands-on, then your understanding goes to a different level of the problem. So once also in parallel you develop your manufacturing skills, prototyping skills, fabrication skills. any product you have in mind, you should be able to quickly bring it to life. So that is what this digital manufacturing enables. And once you have that skill, along with you start doing and developing a better understanding of the problem that you are trying to solve, then you can go on to graduate to develop real new products, new solutions, inventions, and so on. So these fab labs go a long way in enabling the students to do that. Otherwise, without proper tools, you cannot, invent something, or you cannot develop something. So these fab labs equip you with the right set of tools, so that it empowers the students to first start learning by doing, and then they can eventually graduate to real product development, inventions, innovations, and so on. Yes, so makers culture, DIY culture is very important. For example, today in TV shows, if you see a super singer is more popular than playing a movie song. That is DIY, recreating the music. Then a real person is recreating a music. Even if you go to a wedding, a real music concert is more valuable than just playing a background music in a loudspeaker, right? So these are all DIY in music. Similarly, DIY, do it yourself, in manufacturing and product development is very important. At a student level, when you talk about product development, if it is a software product, right? If there is a bug in the product, then you can release a new version 2.0, 3.0 at no extra cost. You can easily fix the mistakes in your software product. But if there is a mistake in the hardware product, then the cost of correcting that mistake is very expensive. Phones got wiped out of the market because the batteries, there was a small problem. So, or we see cars getting recalled because there is a small problem in a airbag or something like that. So what I'm trying to say is hardware product development has a lot of challenges, and students need to equip themselves by practicing, learning by doing, hands-on, to become real engineers in core engineering areas. That is very important. And once they start this learning by doing culture, then they develop better understanding, they improve their manufacturing skills, product development skills, then they can go on to develop real products. I would like to show a few YouTube links that you can refer, where how you can see how some of the professors in the US and UK, they are working on their labs, they are tinkering hands-on, in their workshop, woodworking workshop, and they have gone on to develop patented commercial products, which is earning millions of dollars in revenues. So those are classic examples of how you work in a hardware tinkerer's lab, you work hands-on, you develop something, and then eventually you refine it, and then you can commercialize it, patent it, and then make more money and revenue for the economy, for the country, and so on. So the makers culture, DIY culture is very important. That is the founding stone for any product development, invention, innovations, and so on. So we are basically developing, as I said, that SVP laser. We are developing various digital manufacturing related products. Some of our products like CNC router machines, CNC plasma cutting, CNC gas cutting machines, CMM coordinate measurement machines, robo CNC. We also develop our own indigenous CNC controllers, multi-CNC, CAM software, AutoCAM 2D, which we do in partnership with Autodesk. Like that, we are developing the whole set of technology needed for these digital manufacturing machines, which we can customize for various industrial applications. So we develop machines both for the educational community, where colleges can buy our machines and students can use for their research projects, academic projects, and so on. We also build machines for various industrial applications, like CNC jewelry manufacturing, PCB manufacturing, interior decoration, CNC foam design cutting machines, and so on. So we also set up what is called Make in India clubs, student clubs in colleges, to spur innovation among students, where we encourage students to develop to start with learning by doing. They do existing projects, and then they can do some innovations on top of it. So that is something we do, and these are very set of powerful tools. What I said, in our own industry, when we deliver machines to our customers, we use these machines extensively for when we are developing a new product, a new attachment to the CNC machine, a new sensor, or a new automation we use extensively. It has helped us to do a lot of innovation. For example, we have been recognized as the top IP driven industry, small scale industry in India by CII. We have also been recognized as the best startup in manufacturing in India by CII. So I would say these digital manufacturing tools helped us a long way in developing our products quickly, because each customer, there are different demands from different industries. We need to customize the machines, and each development cycle can eat up a lot of time unless you have this quick prototyping power to quickly develop your product, test it, find the mistakes, correct it, go through this cycle multiple times and deliver the product that works. So it's a really useful technology for the entire community, education, be it education community, maker community, small scale industry or large scale industry where they want to do Kaizen and all that. So it's a very powerful tool, and we are developing some of these machines and technologies. We are doing several joint work with various academic institutes in and around Tamil Nadu as well as across India. For example, with IIT Madras has a center for innovation where the students come in and do a lot of innovative projects. So we have supplied our CNC machines and automation products to them. The CFI students also participate in the International Formula One student car racing event in Germany, and we have been associated with them as a manufacturing partner for them to help them, prototype various components that goes into the Formula One car that they build.
So I am Mahesh Panchagnula. I am a faculty member of the Department of Applied Mechanics. I am also the advisor for co-curricular activities at IIT Madras. Center for Innovation falls under the Dean of Students office and under my ambit. It has been embraced very well by our students. We've had several students who have already taken advantage of its versatile machining ability. Prior to this, we had a rapid prototyping and additive machining facility and a subtractive machining facility. We look forward to many years of useful service by this machine, and students' creativity being brought out in the form of real cut parts.
Hi,
Thank you again.
Personally, I'm a part of the Robocon team, which represents IIT Madras at a robotics competition every year. So having such a machine in C5 has its own advantages, because we can cut small things like flanges, some metal pieces which we require for joining the various robot parts which we make. So all those things can be made instantaneously after we have a SolidWorks file. Whereas before we had to go to various places in Velachery to the workshop, and that has become very, very useful right now. So certainly this is going to be very useful for all the students who work in C5, for all the academic projects, for all the C5 related projects.
We are also doing two DST funded projects with IIT Madras as the academic partner and SVP Laser as the industry partner, where under the UAY Uchchatar Avishkar Yojana scheme and the AMT Advanced Manufacturing Technology scheme, where we are developing large scale CNC prototyping machines. And even at IIITDM we have set up a student club called the Make in India Club, where students come in and develop a lot of innovative projects in these machines. So these are some of the work we are doing with the academic institutes. Thank you.
So what you're seeing here is a CNC router, which is a 3-axis CNC router, and it has 3 axes, which is X, Y and Z. So this CNC router, you can see this is the X axis. So my colleague will be moving the axis. So this is X plus movement, and if you move in the X minus, it will move this way. So you can see, and this is the Z axis, and if you move in the upper direction, it's actually plus movement, and if you move in the downward direction, it's minus movement. So you can see it's moving now. And this is the Y axis. So if I give Y plus, it is moving forward. I hope you can see that. And if you come back, it's Y minus. So this actually represents a typical graph. If you see, when you plot a graph, you will mostly see the x and y axis. So if you just see this machine from the top, you will be seeing the x and y axis. So if it was moving in x plus direction, even in your graph it moves in the x plus direction. Same for the x minus, and in y plus and then y minus, same as your graph. The only thing missing in your normal 2D graph is the z axis. So if you see the z axis, the upward direction is positive and the downward direction is negative. And this machine uses ball screw to convert the rotary motion of the stepper motor over here into linear motion with a ball screw. So when the stepper motor rotates, the ball screw also rotates, and because the pitch of the ball screw is 5 mm, for every rotation the ball screw moves by 5 mm. So in the z axis we have a 3 mm pitch ball screw. The smaller the pitch, the more precision, the more accuracy you get, but also you compromise on the speed. And in y axis we have a 10 mm pitch ball screw. So this CNC machine actually uses ball screw because it's much more precise. We get much precise parts when you cut it out. But there are other CNC machines also where you can have it as a timer belt which converts the rotary motion into linear motion, and there is also a rack and pinion arrangement. And the advantages, the pros and cons are varying. For example, in ball screw you will have very little speed, but you will have very good accuracy because the ball screw pitch is 5 mm. In one rotation it moves only 5 mm. But if you see timer belt, it has teeth, so there is a huge pitch between the teeth, and because of the pulley, the motion is much faster even for the smallest movement or rotation in the stepper motor. The same is with rack and pinion. In rack and pinion we use a pinion which rolls onto a rack, and because it depends on the module obviously, but even if you take a one module rack, the speed is much faster compared to a ball screw machine. In the order, if you see, the timer belt is much faster, and then it's the rack and pinion, and then it's the ball screw. The same with the accuracy. The accuracy is lowest in the timer belt, then with the rack and pinion, and then it's the best with the ball screw machine. So as the speed decreases, the accuracy is also increasing in these mechanisms. In this machine we are having stepper motors. These three are the stepper motors, and we are using a coupling to couple the stepper motor shaft to the ball screw. And these stepper motors are very low cost, and they are much more they are very reliable. It does not mean that it's not reliable. If you use the right optimal parameters for a machine when purchasing a stepper motor, you can get very good accuracy even with stepper motors. Although bigger industrial machines use servo motors which have a feedback also. And in this machine we also have a router. That's why it's called a CNC router. Basically this is a router and this is the CNC. Without this it's just a CNC, and with this it's called a CNC router. This is actually a manual router which people use for wood carving, and we have just mounted this on the machine, and there is a small tool you can see in. So I'll just give a small introduction of the tools. So what you're seeing here is a chip breaker tool. It's called a chip breaker, or also it's called a burr cutter. The reason it's called a chip breaker is because normally when you're using an end mill, which I'll be showing you later, it produces chips in curled forms. So we don't want that sometimes because the chips are very heavy and they cannot be sucked by a dust collector. So we use this actually, which is called a chip breaker or a burr cutter, and what it does is it breaks the chips into powder. So the powder is very much light in weight and it can be easily sucked up by the dust collector. So that is why we are using this chip breaker, and it has a very rough edge compared to an end mill. So I have here which is an end mill. So I have here which is an end mill. This is an end mill, and you can see it just has a flute. This is a 2-flute end mill, by the way, and in this also there are flutes, but there's a difference. You can see it has some sharp edges like a hacksaw. If you see a hacksaw, it has some serrated edges, and this helps in actually breaking the chips into powder. This doesn't have any such thing, so it produces a curled chip, and because of that you will have the chips will be very heavy and they cannot be sucked by a dust collector, which is actually very important when using a router. To suck the dust which is produced while cutting, it will be better if you use a chip breaker than an end mill. Obviously you cannot use chip breakers for ferrous metals or non-ferrous metals, because it'll easily get worn out, and it's not meant for that application. That is why we use the end mill for those applications. So end mill can be used mostly for plastics and for metals, ferrous or non-ferrous metals, and the chip breaker can be used for non-metals, composites, like carbon fiber, glass fiber, and then we have MDF. MDF is medium density fiber board, and then we have Nova pan, and then we have high lam or bakelite, which is also called, and it's very good for those materials because it instantly turns those materials into powder, and they can be easily sucked up by the the dust collector. In case of the end mill, even though the chips are produced, and it's because it's used for plastics and metals, even if the chips are produced, they cannot be sucked up by the dust collector. So there's no point in using the chip breaker for that application. And so here we have a ball nose end mill. The difference between a normal end mill, which is here, which I've shown you before, and a ball nose end mill is here the end mill is flat at the top, and here we have a small radius at the top. So the ball nose end mill is used mostly for 3D carving, where you get a very smooth finish on the surface, and it looks very aesthetic. If you use the same end mill, you will have some lines on that 3D carved surface. So that's why we use a ball nose end mill. It's very much similar. The flutes, it has the same flutes. It is actually a tapered end mill because it can go through small corners and other places where it's difficult to access by a normal end mill. So and it also increases the strength of the end mill. As it is tapering, it will not break easily compared to a normal end mill. The ball, you can see there is a ball tip and it has a radius. So the smaller the radius, the better the finish, but the material removal rate will also be lower. So there's a trade-off in this using the ball nose end mill, but the biggest advantage is because you get very good finish. That's why we use a ball nose end mill. This is also another chip breaker, but it's a bit different. It's actually a diamond type chip breaker. You can see it has those pyramid shapes on this compared to when using this. So this is actually much aggressive and can be used for cutting harder composites, although even this can cut, but this is much better, and it can be used to cut glass fiber and carbon fiber very effectively. And this is a 6 mm end mill. It's much stronger and it doesn't break easily when compared to the 3 mm chip breaker. So what we have over here right now is a chip breaker, and the Bosch router, we can actually adjust the speed with this dial over here. So since we are cutting a material which is called coroplast, it's a plastic material, so we'll have to cut at the lowest RPM possible. So the machine is running, connections are fine, so we will just run this machine. So to start the cutting, we first have to turn on this router. So we just turn on the switch. So you can see the router is turned on. And then we just click execute.